Hey guys, today we're going to do Chapter 3, Lesson 3, Accumulation Functions in Applied Contexts. The velocity of an object in motion is not the only rate that we can integrate to get an amount. We have seen that accumulation or net change problems present us with a scenario where we're often asked to calculate the value of some quantity accumulated over time, and we can solve these problems using definite integrals. You receive a 10-week-old Basset Hound puppy for your birthday and discover that he's gaining weight at a rate of e to the 0.0125 t pounds per week, where t is the puppy's age in weeks. At 10 weeks, the puppy initially weighed 14 pounds. What is the expected weight of your new puppy at the end of week 15? So our initial condition, 14, plus gaining weight from weeks 10 to 15 of our function. And we know it's going to be an approximation because e is involved. So math 9 from 10 to 15 of e 0.0125x dx and plus 14, 19.846 pounds. An electric monorail transport is slowing down at a rate of 2t plus 25 feet per second, where t is the time in seconds. By how many feet per second does the monorail slow down between 1 and 5 seconds? So you're looking for velocity, which means you need the antiderivative of acceleration from 1 to 5 seconds. Now that's a pretty simple antiderivative. So 25 plus 125 minus 1 plus 25. So that looks like 150 minus 26, which is 124 feet per second. And I will go ahead and tell you, and you may want to make a note, that is one I would expect you to be able to do without a calculator. The number of liters of oil in a tank is changing at a rate of 0.26 t liters per minute, where t is the time in minutes. Initially, the tank contained 14 liters of oil. Write an expression that can be used to find the amount of oil in the tank after 10 minutes. So that initial condition plus time from 0 to 10 of your function is 14 plus 0.13 t squared from 0 to 10 is 14 plus 0.13 times 10 squared is 13, so 27 liters. In interpreting expressions, these is one of those problems where it's just a scenario, so I've written them in for you. The function w of t gives the number of water bottles produced by a manufacturer by time t in hours on a given day. Explain the meaning of the expression. So this is the number of water bottles produced from hours 4 to 8. The amount of oil being drained from your pickup truck is decreasing at a rate of r of t quarts per minute, where t is the time in minutes. What does the expression mean? So during the fourth minute, so we've gone from 3 to 4 minutes. During the fourth minute, the amount of oil being drained from the truck is decreasing by half a quart. Kevin got a gift of $500 from his grandparents for graduation. He deposited the gift into his college savings account. Kevin's savings grows each month at a rate of r of t hundreds of dollars each month. What does the expression below mean? So 5 is your initial condition. So from months 1 to 12, by the end of the 12th month, his account has a total of $2,400 in it. A city bus is accelerating from 0 to 18 seconds. The data for the acceleration is recorded in the table below. If the velocity at time t equals 0 is 6 feet per second, find the approximate velocity at t equals 18 using a trapezoidal sum. So you know v of 0 equals 6. So v of 18 is going to be v of 0 plus the range from 0 to 18 of acceleration. We're going to use a trapezoidal sum. B sub 0 is 6 plus 1/2 times change is 3 trapezoidal sum. So 1 plus 2 times 4 plus 2 times 6 plus 2 times 8 plus 2 times 7 plus 2 times 9 plus 10. Remember, in that trapezoidal rule, everything is multiplied by 2 except the first and the last. So using your calculator, you should get 124.5 feet per second. Accumulation from a graph. The graph at the right shows the rate in gallons per hour at which stormwater is being pumped from an overflowing canal. Find the approximate number of gallons pumped from the canal in the 24-hour period. Now, this is something that I anticipate that you should be able to do on your own. However, looking at this graph, I will tell you that it is kind of hard to estimate where these points fall. So I'm going to give you that information here. So gallons of stormwater is found by going from 0 to 24 of the function graphed. So this is approximately 1/2. Delta x is 4. Again, we're going to do that trapezoidal rule. So 0, 100 plus 2 times 125. That one's not too bad. Plus 2 times, we'll say that one's about 135. Plus 2 times 130. Plus 2 times 110. Plus 2 times 85. Plus 65. And again, those are very much approximations according to what we see here on the graph. So using your calculator, you should get 2,670 gallons. Again, don't just write down the answer. Use your calculator to check to make sure you know what you're doing there. Find the cost to produce 50 widgets if the initial cost is $1,800, initial cost. And C prime of x is 155 minus 30x plus x squared. Let x be the number of items of a widget produced. Let C of x be the cost to produce x widgets. C prime is your marginal cost, which is the cost to produce one additional widget if currently x items are produced. So C prime of x is going to be approximately C of x plus 1 minus C of x. So the cost of 50 minus the cost of 0. There's your marginal cost. Is going to be the cost from 0 to 50 of C prime of x dx. Now, we've got those formulas way in our notes, way back. So those I told you would come up from time to time. 155 minus 30x plus x squared dx. Now, anytime you have a polynomial, it's not a bad idea to practice finding that antiderivative and then evaluating that definite integral. Math 9 would check that for you as well if you chose to do it that way. Then you get 11,916.666. So the cost of 50 would be that value. Plus your initial cost of $1,800. So the total cost of producing 50 widgets is $13,716.67. As always, let me know if you have any questions. I hope y'all have a great day.